right, guys, so today we are looking at section 5.2, part 2. So you're going to scroll down in your notes until you get to page 6 is where these start. So what we're going to be doing today is we're going to be taking roots of variables. Up to now, when we took a root of a variable, I made it so that you really didn't have to worry about using absolute value. But today we're going to have to worry about when we have to use absolute value. So the directions say, write the expression in simplest form. Use absolute value when necessary. We need to use absolute value when we do not know if x is positive or negative. For example, the square root of x squared. That would be a problem where I would have to see whether or not I use absolute value. I want you to think about this. What if I asked you the square root of -3 squared? Well, you would do -3 squared first, and what do you get? What's -3 squared, everybody? And then what's the square root of 9? 3. So if we did this problem, the x value actually started as -3. But our answer is not equivalent to x. It's actually the absolute value of this that ends up being our answer. So what happens is, if I have to do the square root of x squared, I can't just say the square root of x squared is x, because it isn't in all cases. If our x is a negative, our answer ends up being a positive. So I have to use absolute value on it. That's what we have to get at on this problem. The absolute value must be used if I'm taking the square root of x squared. Let's talk about now if we take the cube root of x to the third. Would we need absolute value? Well, let's check it out. Let's do the cube root of -2 cubed. X in this case is -2. What is -2 cubed? -8. What is the cube root of -8? What's the cube root of -8? -2. So when our x was -2, was our answer still -2? Yes. So when we take the cube root of x to the third, that is just going to be equal to x. I'm not going to have to use absolute value. What do you think we could do to figure out when we need absolute value? Why did we not need it here? What is true of this root that we're taking? What kind of number is it? Odd. So when we have an odd root, we do not need to use absolute value. But if we have an even root, we might need to use absolute value. Okay? Let me jot that down. Even root might need absolute value. Odd root never needs absolute value. But there are some times when I don't need absolute value when I have an even root. It would be a case like this. Let's say I'm taking the square root of -2 to the 4th power. What is -2 to the 4th? 16. What is the square root of 16? What is the square root of 16? 4. So our x value started off being a negative, right? This is the same thing as doing the square root of x to the 4th. What's the square root of x to the 4th? X to the what? 2nd, right? The square root of x to the 4th is x to the 2nd. I don't need to use absolute value on this. Do you see how, even though x started off as a negative number, my answer ended up positive? So I don't need absolute value in this case. So here's what we're looking at. When we're working with radical expressions, this absolute value requirement does not apply to any odd root, like up here, because odd roots can have negative answers. I want you to be thinking about, though, what do you think is meant by the even, odd rule? The even, odd rule, this is when you have even, odd, you need absolute value. But what do we mean by this? What do you think is meant by the even, odd rule? That's when we need absolute value, is when we have even, odd. I want you guys to think of these 5 problems. You can work with a partner, and I want you to decide whether or not you need absolute value, and then I want us to come back and talk about this even, odd rule. Try it. All right, so let's come back together, and I want to see what you guys think on these. Will, what did you put for the 4th root of x to the 4th? The 4th root of something to the 4th is just going to be what? Do you guys agree with x? Would we need absolute value on it? A lot of people are shaking their heads yes, and that is true. That's the example I just showed you here. Something similar to this. Well, actually not this one. You'd have to go back up to this one. We do need absolute value here because x could be a negative number. When we raise it to the 4th, it would become positive, and then the 4th root of that would be positive, but x was originally negative. Okay? What is the answer to the 4th root of x to the 8th? X squared. Do you think we need absolute value? What would be true of x squared? It would always be what? Positive. So we would not need absolute value if it's going to be positive anyway. What about the cube root of x to the 3rd? What's that going to be? X. Do we need absolute value? No. We never need, odd roots never need absolute value. If it's an odd root, it will never need absolute value. Okay, what about the cube root of x to the 6th? What's that answer going to be, guys? X to the 2nd. Do we need absolute value? No. Okay, what about the 6th root of x to the 18th? X to the what? X to the 3rd. Here's how we're getting that, you guys. All you have to do is take this power and divide it by the root. That's how we're getting it. Do you think we need absolute value? Yes. Now, let's go back here. We need absolute value whenever we have even, odd. What is this even, odd referring to, though? At the beginning of the problem, if we have, all right, go ahead.
Is it because like at the first one, it's like it has an even, like 4 is even, and then the 4, and then but then the x is odd.
Correct. She is right. So at the beginning of the problem, if we have an even root, an even power, but then at the end, we have an odd power, that is when we need absolute value. Look, on this problem, at the beginning, I have an even root, I have an even power, but at the end, my answer has an odd power. On this one, at the beginning, I have an even root, I have an even power, but at the end, I have a what? Even power. So I don't need absolute value, because this is going to be positive anyway. It's redundant to put in an absolute value if it's already going to be positive. I don't need it here. It's not an even root. I can stop. There's not an even root. Look at this one. Even root, even power, odd power at the end. So if you want to memorize that, fine, go ahead. I prefer that you really understand why, and it's based on that whole fact that x could be negative at the beginning, but the answer would not be negative, and that's the reason why we have to think of it that way. All right, now we're going to try some problems. We're going to add something else on here. So absolute value is the first difficult concept with this. The next difficult concept is what we call restrictions. Okay, that's what I'm going to talk about now. Write each of the following in simplest form. When simplifying radicals with variables, we also must state restrictions on the variables if there are values that originally made the function undefined, but those values do not make the simplified function undefined. For example, in number 20, you must write d cannot equal 0 with your answer, because d cannot equal 0 in the original problem, but d can be 0 in the simplified answer. All right, let's break this apart and see if we can understand what's going on here. The first thing we always do when we have a problem is we want to divide if we can. So, can I divide d to the 13th divided by d to the 1st? What do I get? D to the what? 13, d to the 13th divided by d to the 1st would be d to the 12th, right? So first I'm going to simplify. Now, what is the cube root of negative 27? Negative 3. What is the cube root of d to the 12th? D to the 4th. Okay, so we think, oh, pretty easy problem. Do we need absolute value? You should immediately say no. Why should we say no immediately? Odd roots. Odd roots never need absolute value. Okay, so we don't need absolute value. But at the beginning, if d is 0, this function is undefined. Do you all remember how you're not allowed to divide by 0? If you divide by 0, something is undefined. So in this original problem, if d is 0, the function is undefined. However, is the function undefined here if d is 0? No, because what is this over top of if there's nothing under it? 1. So if d is 0 here, the answer is 0. But if d is 0 here, the answer is undefined. So therefore, I am saying this is exactly the same as this, as long as d does not equal 0. That is our answer. And that is difficult for people to understand why we have to make this statement. But these two are equivalent for every d value. If d is 1, 2, 3, negative 7, no matter what, these are equivalent, except for they're not going to be equivalent when d is 0. So I'm saying this is equal to that as long as d does not equal 0. Okay? All right. Let's try this problem now. We have the 4th root of 16. Well, first we should see if we can simplify. We cannot. What is the 4th root of 16, everyone? 2. What is the fourth root of x to the fourth? X. What is the fourth root of y to the 12th? Y to the third. What is the fourth root of 81? What's the fourth root of z to the fourth? Okay. Now, the first thing we check for is absolute value. Do we need absolute value around any or all of these variables? Some people are saying all. Do we agree all of them? Why? Even root, even power, odd at the end. Should I put absolute value around the 2 and the 3? No, they're not variables. Constants will never have absolute value when we're simplifying. But I do need absolute value here, and I do need absolute value here. So the first thing I always want to check for on these simplifying problems is absolute value. The second thing I always have to check for, which makes the problems difficult, are restrictions. I have to check for both of those things. We took care of the absolute value. Do I need a restriction? Is there if z is 0 here, and if z is 0 here, do I get the same result? I do, don't I? If z is 0 here, this is undefined. If 0 is equal 0, if z is equal to 0 here, the function is undefined. Do I need to say z cannot equal 0? No, because they have the same answer. I don't need to write it. I can see that z cannot equal 0 in both of these. So therefore, I do not need a restriction. Okay? All right, let's look at this one. Fourth root of 16x to the 36. Got a lot of things going on here. I always like to simplify first, divide anything that I can. Okay, so I have the fourth root of 16. Now, if I have x to the 36, I'm just going to do this one step at a time. Everybody with me on how I did that? I just kept the top the same for now. These two, I kept that fourth root because they have the same root, and I have 81. Bases are alike, so I add those exponents, x to the fourth. Good? Okay, so now let's keep going. So now we're going to have the fourth root of, the 16 is going to stay, 81 is going to stay. What do we do when we're dividing and those bases are alike? What do we do with the exponents? Subtract them, right? So what am I going to have then? X to the what? 32nd. So we always want to simplify first to make the problem a bit easier. Now, what is the fourth root of 16? 2. What is the fourth root of x to the 32nd? X to the 8th, right? What's the fourth root of 81? 3. We have to check for two things. Do we need absolute value, and do we need restrictions? What do you think? Do we need absolute value? Yes or no? A lot of people are saying no. Sam, why do you say no?
Because it would be redundant power.
Good. We do have an even at the beginning, and we do have an even here, but at the end we end up with an even, which is going to make this x positive no matter what. So therefore, putting absolute value is like not needed. We know it's going to be positive anyway. Okay, so no for the absolute value. What about on the restriction? Yes or no? Yes? Some people are saying, who will tell me why it's yes? You're right, it is yes. Brooklyn?
Because, like, in the original, there's an X on the bottom
Correct. So because at the beginning, if x is 0, it's undefined. But at the end, if x is 0, I just get 2/3 times 0, which is 0. I don't get the same answer when x is 0. So what I'm saying is this is exactly the same as that as long as x does not equal 0. If x is 0, that one's undefined and this one is 0. I don't get the same answer. And we're trying to simplify. Very good. Now, like I said, I'm not big on rules. I don't really like you memorizing rules if you don't understand why they work. But let's kind of write out, when do we need a restriction? Brooklyn said it pretty clearly just a minute ago. Can somebody kind of say the same thing, but what do you think, Lucas?
When there's a variable at the bottom, we can move without that.
Okay, so original has variable in the denominator. End does not, right? That's when we need it. When the original problem has a variable in the denominator, but the end does not have that variable in the denominator. Okay, so keeping that in mind. All right, let's do this last one here. Okay, checking it out. Lots going on here. It looks pretty complicated, doesn't it? But what I like to do is take it one step at a time. I like to get rid of negative exponents first. How do I get rid of negative exponents? Just move its location, guys. If it's on the top, take it to the bottom, and then it becomes a positive exponent. Okay? So my 21 is going to stay where it is. What about the x to the negative 3/2? Should it stay or move to the bottom? Move to the bottom. So I took care of this. This is going to the bottom. Now, square root of y, that's going to stay on top, but I don't want to use square root of y. I need to keep all of these with the same type of notation. So how can I write y, the square root of y with a rational exponent? Y, good, y to the 1/2. Just do that. Okay, this y to the 1/2 is going to stay where it is. Cross it out as you go. Z to the 5/2 stays where it is. What about 7 to the negative 1? Where's that going to have to go? Up to the top to make it a positive. Z is going to stay where it is. And then how do I write the square root of x? X to the what? 1/2, guys. Square root of x is x to the 1/2. All right, let's start simplifying. 7 times 21 is 147. What do I do when I'm multiplying and my bases are alike? What do I do with the exponents? Add them. So what am I going to have? Just what? Just y. So I took care of those. I took care of that. All right, let's see what else we got. We have a z here on top and a z here on bottom. Bases are alike and I'm dividing. What do I do with the exponents? Subtract. What's 5/2 minus 1? 3/2. Very nice. So I'm going to have z to the 3/2. That's gone. That's gone. Take it one step at a time. X to the 3/2, x to the 1/2. I'm multiplying and my bases are alike. What are we going to do? Add the exponents. What do I get? X to the second, right? All right, we are making good progress. I would allow you to give me this answer, but we now have to check, do we need any absolute value? Let's see with the y. Do you think we need it on the y? You don't think so? Let's look. We had even. Actually, we really don't, do we? Because we've got even, and then that was to the first, and that's really to the first. Okay, I agree. We don't really have to have it there. What about on the z? We're taking the square root. That was odd, so it could be negative. Okay, I don't think we need it around the z either. And on the x, we definitely don't. And why do I say that? Because of what? That even exponent, right? Okay, so we don't need absolute value. What about restrictions? Do we need any restrictions? Check it out. Is the x okay? Yeah. Is the z okay? No. So what am I going to say then? Z cannot equal 0. Because if z equals 0, that one's undefined. This one would just be 0. So this would be a fine answer. If I made this multiple choice, though, I would probably write it like this. Would you understand why that is equivalent right there? You've got the square root of z cubed. Can you see why that would end up being z radical z? Could you get to that? Yeah, I think you could. All right. Any questions? All right, so that was a lot. But your homework's up here. You got section 5.2, part 2. You'll notice you don't have many problems to do, so I want you to do them carefully. If you have variables, you have to check for absolute value unless you see this term right here where it says, if it says assume all variables are positive, then you don't even have to worry about absolute value. But I think it only says that on a couple of the problems. Okay? All right. Good job, guys.